Hello everyone, welcome back to the class real-time systems. Today we are going to discuss about scheduling strategies. See earlier, so far we have discussed about the introduction to the real-time systems. I mean the introduction to the operating system and also a multitasking operating system. So in introduction we have talked about what is a real-time operating system and what is the functions which is there, what is the typical structures of the operating system. If it is a blood operating system, how it will be. So those things we have discussed in that, and also we have discussed about multitasking operating system. So in that multiple task which performs parallelly simultaneously. Okay, so in that we discussed about the multi-user and also a multitasking operating system. So the difference between the multitasking and multi-user we have talked about. So the multi-user operating system, the multiple user which executes their code, well, the different code, and also they uses the different data for that. Okay, and this will be executed in protected environment. Okay, so this is what multi-user operating system. In multitasking operating system, so there is a single user. In single user the program need to execute, that program will be divided into the number of tasks. So the each task which executes their own, I mean simultaneously which executes, and that whatever the data which is used in that particular program, it will be shared by the task. Okay, so the data will be stored into the common area and that will be used. So here there will be a inter-task communication between this is available. Okay, that is what we have discussed in the previous video. Now we are going to discuss about the scheduling strategies. So the first of all, scheduling is nothing but the allocation of the CPU for that to program. Okay, so the which program will be selected for execution of CPU. Okay, under the CPU execution. So that is nothing but a scheduling strategy. Scheduling. Okay, so scheduling is nothing but the time allocation on a single CPU. The CPU will be allocated for that particular program execution. So which program will be selected for that particular execution, that is nothing but a scheduling. Okay, simply which is called the selection of the program under the CPU execution. Okay, so in that there are two strategies are there. One is the cyclic scheduling and also here the preemptive scheduling. So first of all, cyclic is nothing but it is, what does that mean represents? The cyclic is represent, it is keep on rotating. It is keep on rotating. That means that the CPU will be allocated to the task in turn. So here we are talking about the scheduling. Scheduling is nothing but selection of the program for CPU execution. Okay, so in that the one of the type is nothing but a cyclic scheduling. That means the CPU will be allocated to the task in turn, one by one, first come first out. Based on that, the CPU will be allocated to the program. So it takes the use of the CPU as long as it wishes. Okay, so each and every task can use a CPU until the completions of the work. Okay, when no longer which is required for that particular task, so then the scheduler allocate that particular CPU into the next task in the list. Okay, and this cyclic scheduling is is nothing but on the simple scheduling and also highly effective strategy for the small embedded system, and there is no time is wasted in between switching the task. Okay, and the task unit should have a similar execution time, cannot deal with the random event. So the cyclic scheduling cannot be deal with the random event. So based on the arrival, the CPU will be allocated to each and every task, and then how much it is required, they can use the each and every task, they can use the CPU, and also there is no longer required for the scheduling, allocates to the next task in the list. Okay, and it is a very simple and highly effective strategy for the small embedded system, and the switching time is very less. There is no time wasted in between the task, in between the switching task. And the next one is preemptive scheduling strategy. Preemptive is nothing but removing the program from the CPU execution once the predefined time is completed. It is nothing but preemptive scheduling. Okay, so it involves the possibility of the task is being interrupted before it has completed a particular invocation. Okay, so what is that? It involves the possibility of the task is being interrupted. So the task is being interrupted before going to complete that particular task. There is a possibility of interruptions in that particular event. Okay, so the execution has to make a provision for context switching as it may have to resume at the some point in a time. See, for example, the number of tasks which is there in the queue, the one program will be selected for the CPU execution. That program will be executing under the CPU. So the predefined time is allocated. Once if it is completed, that program will be removed, whether it is completed or not. That will be removed, again it will be put into the queue. Okay, it will be put into the queue. Whenever it is again rescheduling, resuming that particular process, now the CPU wants to execute where it exactly stops earlier. Okay, so for that, so whenever it is preempting the program from the CPU, the state of the current process will be loaded into the um, control block. Okay, so that is a task control block. In the task control block, whatever the current information that will be loaded into the task control block, and that will be put into the queue. Whenever it is rescheduling again, that time it will be loaded the previous information, how it will be executed, and how much it is executed, that will be loaded back to the task and executes the CPU time. So it is called the context switching. Okay, so the execution has to make the provision for context switching, as it may have to resume at all the points in a time. Okay, and the primary concern is to prevent the one program either deliberately or through the error the corrupting another. So okay, so the simplest form of the preemptive scheduling is nothing but a time slicing approach. It is nothing but round robin scheduling. So round robin scheduling is nothing but it is depending on the arrival, it will select one of the process. So always it takes the head of the queue. Okay, it will take the head of the queue. That particular task will be selected for the CPU execution. Okay, and the time slicing is nothing but the time which is allocated for the CPU execution, the predefined time. Okay, so that will be allocated for the execution. So by once if the time is completed, that will be removed and put it back to the queue. So one of the simplest form of the preemptive scheduling is nothing but a time slicing, and also a round robin scheduling with time slice. Okay, each task is allocated to a fixed amount of CPU time. If it is finishes earlier, the next task which begins. Okay, so the majority of existing the real-time operating system uses the priority scheduling mechanisms. Okay, so always we are talking about the real-time operating system. Whenever we are talking about the real-time operating system, the priority which comes into the picture. Okay, so what is a priority? Each and every task there will be a priority. The priority will be assigned. So that priority, it may be on static or it may be on dynamic. During the execution itself, the priority may change. Okay, so that is depending on the application. So okay, so depending on the priority wise, the program will be or the task will be selected from the queue and will be executed under the CPU. Okay, so the tasks are allocated to the priority level. At the end of time slide, the task with the highest priority is allowed to run. Okay, highest priority, which are the tasks which contains, that will be allowed for running the CPU execution. So the task priority could be a static or it may be a dynamic. So the dynamic priority which increases the flexibility of the system, but it is harder to predict the behavior. Okay, so may result in certain task is being locked out for the long period of time. Long period of time. Okay, so this is all about. So that's all about the scheduling strategies. So we have discussed about the scheduling strategy, two types. One is cyclic scheduling and also a preemptive scheduling. We discussed about how the cyclic scheduling which works and the preemptive scheduling which works. Okay, so this is one of the important question and also a repeated question where for a main examination. Okay, I hope this video is very useful for you. We'll meet you in the next video. Thank you.